And here is the interface. The interface allows the transporter user to find a computational service. There are several types of search: by provider, by service name, by service type. We now search a type which is computational, and we find several computational services available in this view. We select one and use this as the service provider to which submit our job. Now, to submit a job, we have to specify a class file. We submit a Java job. The arguments to the program. We keep them in a separate text file. Copy and paste them to the interface. You have to specify the class path. We specify the input file, which are the data on which the computation is run. A properties file, which says to the algorithm how to run. There are some tuning parameters, and the output file name, where the results are written by the algorithm. We want standard output, standard error, and the log back from FTP, and we submit the job, again specifying which is the certificate that identifies this user. While the job runs, we can explain which is the problem that the computation is going to solve. It is a classical operation resource problem named Vehicle Routing Problem with Time Windows, VRPTW. This slide shows the input data of VRPTW. The goal in solving the VRPTW problem is to allocate the given transportation task to the minimum number of vehicles while respecting all time and capacity constraints, and find a set of routes for those vehicles which minimize the total travel distance. This slide shows an example of VRPTW input data with 25 customer tasks to be allocated to vehicles of given capacity. The algorithm to solve the problem is an implementation of the multiple ants colony system proposed by Luca Gambardella for multi-objective optimization. But let's go back to our transporter, who is waiting for the output of the computing job. When the job completes, the transporter gets the results both in graphical and in text format. Here's the number of vehicles and the total distance. Now there is an animation that shows the demo architecture and what happened when submitting and executing the job. In the first step, the transporter, indicated as a VO user, fills in the job submission form and sends both input data and Java code to be executed to the TIA portal. Then the TIA portal submits the requested job to the Grand computational node, which has been previously selected. Note that the Grid Trust services are integrated with the Globus toolkit, so the service used to manage the computation resource is Gram. Gram executed the requested code and calculates a result, while the Yukon component continuously controls that all the executed operations are allowed by security policies. When the computation ends, Yukon sends a reputation feedback to the Trust and Reputation service about the transporter user. In the demonstrated case, the computation didn't violate any policy, so the feedback has been a positive one, which slightly increased the reputation of our user. Otherwise, if the application submitted to the computational service violates a security policy, the Yukon service sends a negative feedback and the user reputation decreases.